Assalamu alaikum dear students. In previous lecture we discussed a slope of line. Now here today we are going to discuss how to find slope of a line when it passes through two given points. Now let L be a line which passes through 2 points, say P of x1 y1 and Q of x2 y2. Now you know that if theta is the angle of inclination, that is when this is the angle which it makes with the positive direction of x-axis. We can define slope for non-vertical lines, and you know that theta lies between 0 and 180. This means that there are two possibilities for this angle of inclination. That first case is when theta is acute angle, that whenever its measure is less than 90, or when theta is obtuse, that is when theta is greater than 90 degree and less than 180 degree. Now we will discuss the case when theta is acute angle. That is, here we have three x1 y1 x2 y2 are two different points, and let's assume that this theta is the angle of inclination which is mixed with the positive direction of x-axis. Now when this theta is acute, now suppose when this theta is acute, this is the required line. Now it makes an angle theta with the positive direction of x-axis. Here this line passes through two different points, P of x1 y1 and Q of x2 y2. From this P and Q draw two perpendiculars on x-axis, that is Pn is perpendicular and Qr is perpendicular. Also join PM. So here this right angled triangle is formed, PMQ right angled at M. Now you know that clearly this PM is x2 minus x1, this QM is y2 minus y1. Here this base angle is given, which implies that in this right angled triangle PMQ, tan theta is simply perpendicular upon base. Perpendicular is y2 minus y1 and this base is x2 minus x1. You know that here theta is angle of inclination. Tan of theta is simply the slope which is denoted by m. Hence in this case when theta is acute, this m, that is slope of this line passing through 2 points x1 y1 and x2 y2, is y2 minus y1 upon x2 minus x1. Now when theta is obtuse, that is whenever its measure is greater than 180. So when theta is greater than greater than 90, that is obtuse, then the line is of this form. It passes through two different points, P of x1 y1 and Q of x2 y2. Here this angle is theta because it is given that it makes an angle theta with the positive direction of x-axis, which implies that this angle is 180 minus theta. 180 minus theta is this angle because it is the linear pair. Now from this P and Q, draw two perpendiculars on x-axis and join this PM. Now clearly this QM is y2 minus y1 and this MP is simply x1 minus x2. Now we have here right angle triangle with base angle is 180 minus Q because this MP is parallel to x-axis. Now here this angle is 180 minus theta, which implies that this angle is also 180 minus theta. So in this triangle, tan of 180 minus theta is simply perpendicular upon base. Here perpendicular is y2 minus y1, base is x1 minus x2. Also tan of 180 minus theta is simply minus tan theta. From denominator it is x1 minus x2. We can write this as minus x2 minus x1. So this minus and minus cancels. It is tan theta is y2 minus y1 upon x2 minus x1, which implies that tan theta is m, that is slope. Slope is simply y2 minus y1 upon x2 minus x1. So in both cases, when angle of inclination is either acute or obtuse, and the given line passes through two different points with coordinates x1 y1 and x2 y2, then its slope is simply ratio of the difference of this ordinates over difference of abscissas, that is y2 minus y1 upon x2 minus x1. Like if we have this line which passes through two different points, 5 2 and 1 minus 2, then its slope is here x1 is 5, y1 is 2, x1 x2 is here 1, y2 is minus 2. This means that the slope of the line passing through two different points p of x1 y1 and q of x2 y2 is y2 minus y1 upon x2 minus x1. Here x1 y1 is 5 2, y x2 y2 is 1 minus 2. You know that the slope m is y2 minus y1 upon x2 minus x1, that is minus 2 minus 2, because x2 is minus 2, y1 is 2, and that is minus 2 upon 1 minus 5, which is minus 4 upon minus 4, that is 1, which implies that the slope of this line is 1, while as the slope of, you can find also, you can find the slope of this line which passes through points minus 1 minus 1 minus 2 minus 2 in the similar way. Now we will check whether, now we will here find the condition for two lines to be parallel or to be perpendicular to each other. Now suppose we have two lines L1 and L2 which are non-vertical lines, because for vertical lines theta is, that angle of inclination is 90, so we cannot define the slopes for such lines. So in slopes we always define either the horizontal lines or non-vertical lines. Now suppose we have two lines L1 and L2 with slopes m1 and m2 respectively. Suppose theta 1 and theta 2 are the angle of inclinations of these two lines. That is, here we have this L1, it makes an angle theta 1 with the x-axis, with the positive direction of x-axis. We have L2, it makes an angle theta 2 with the positive direction of x-axis. Now suppose these two lines are parallel. Suppose that these two lines are parallel, which implies that this angle equals to this angle. Theta 2 equals to theta 1 or theta 1 equals to theta 2. Now when theta 2 equals to theta 1, you know that the theta lies between 0 and 180. In 0 and 180, that is in interval 0 pi, tan of theta is always 1 function. So when it is 1 function, implies that tan of theta 2 equals tan of theta 1. Tan theta 2 is m2, tan theta 1 is m1, which implies that m1 equals to m2. So this means that when these two lines are parallel, implies that their slopes are equal. Now we will prove it conversely. Suppose it is given that the slopes are equal, that is m1 equals to m2. When m1 equals to m2, but m1 is here tan of theta 1, m2 is tan of theta 2, which implies that here tan of theta 1 equals to tan of theta 2. Since it is 1 in the range 0 and 180, this tan function, which implies that theta 1 is simply theta 2. So this means that angle of inclinations of these two lines with the positive direction of x-axis is same, hence we can say that these two lines are parallel. So simply we can say the necessary and sufficient condition for two lines, for two non-vertical lines to be parallel, is that their slope should be equal. That is, whenever lines are parallel, implies that their slopes are equal, or whenever slopes are equal, implies that these two lines are parallel. That is, m1 equals to m2 is the condition for parallelism between the two lines. Now we will find the condition of perpendicularity between the two lines. That is, we have to find the condition in terms of slope, which gives us the criteria between two lines to be orthogonal. Orthogonal means orthogonal lines are those lines which are perpendicular to each other. Now suppose we have two lines L1 and L2 with slope m1 m2, that is tan of theta 1 and theta 2 are the angle of inclinations respectively. That is, here we have this line L1, it makes an angle theta 1 with the positive direction of x-axis. We have this L2, angle of inclination is theta 2. Now suppose these two lines are perpendicular, that's angle between these two lines is 90. So this means that this angle is 90, this is 90, this is 90, this is 90. Now in this triangle, we have this triangle ABC. You know that sum of angles of a triangle is 180. So in this triangle we have three angles, angle A, angle B and angle C. clearly here angle, this angle C is 90, so it is here 90. Angle B is here theta 1, because angle B is the angle of inclination of line L1, so it is theta 1, which implies that simply we can say that angle A equals to 180 minus theta 2. 180 minus theta 2. Now we have 3 in this 180 minus theta 2. Now we have 3 this and this substitute all these values, all such values in this. Angle A is given, angle B is given, angle C is given. Now using this we can simply say that minus theta 2 plus theta 1 plus 90 is 0, or theta 2 is simply theta 1 plus 90, which implies that tan of theta 2 is tan of theta 1 plus 90. Tan theta 2 is simply minus cot theta 1, because tan of 90 plus theta is minus cot theta. Or we can simply say that it is tan of theta 2 is equals to minus 1 upon tan of theta 1, minus tan of theta 1. But tan of theta 2 is m2, tan of theta 1 is m1, which implies that m2 equals to minus 1 upon m1, or m1 into m2 is minus 1. So this means that whenever these two lines are perpendicular, implies that their product of slopes equals to minus 1. Similarly, you can prove it conversely, that is whenever this m1 into m2 is minus 1, that is product of any two lines of a slopes is minus 1, then these two lines are always orthogonal, or simply they are perpendicular to each other. So this is the necessary and sufficient condition for two lines to be perpendicular. So simply we can say that if we have two lines with slopes m1 and m2, if m1 equals to m2, this means that these two lines are parallel. Whenever m1 into m2 is minus 1, then we can simply say that these two lines are perpendicular to each other. So thank you.